so this is review from 2-5 day 3, where we have to remind ourselves what types of absolute value equations have two solutions and what types of absolute value equations have no solutions. If our answer is a negative number, so in this case negative 11, there are no solutions because absolute value is always a positive number, a positive distance from 0. It cannot be negative. So there is nothing that I can take the absolute value of and get a negative number. If my answer in this case, which is 3, is positive, that is okay. We can have an absolute value that ends up in positive 3. So with all the positive solutions, I'm going to bring them over to the 2 solution circle. And if I have a negative answer, I'm going to bring it over to the no solution circle. So notice how all of these are negative. All of these are positive. All right. First thing we're going to do is write your own absolute value equation that has 2 solutions. All right, so I know I need absolute value bars, so I'm going to start with those. And I know it needs to have 2 solutions, so that means this number right here has to be positive. I'm just going to make something up. I'm going to say it's 10. Now really, whatever I put in my absolute value bars doesn't really matter. I'm just going to make sure I have a couple and a third wheel. Now if I solve this, since it's a positive solution, I can do case 1 and case 2. So just a reminder, case 1 stays the same, except you drop the absolute value bars. Case 2, the thing that changes is my answer, or what's next to the equal sign, becomes negative 10. So case 1 is positive 10, case 2 is negative 10. I can draw my train tracks for both equations and solve both of them. Add 5 to both sides. 2x equals 15. Break up my couple, and I'm left with x equals 7.5. So there's one of my solutions. Couple is 2x, get rid of my third wheel, so add 5 to both sides. 2x equals negative 5. Break up my couple, and I'm left with x equals negative 2.5. So there is my solution. All right, so we did this first part. Now we're on to the second part. It says, now write an absolute value equation that has no solution. Okay, so I'm going to erase what I have up here now so I have a little bit more space. Okay, so now if I look back to the last slide, okay, if I want it to have no solutions, what do I need? Oh, I need my whatever is to the right of the equal sign, or by itself on the equal sign, to be negative. So I'll draw my absolute value bars, and then I need this to be a negative number. I'll just pick negative 5. I can write any equation I want on this side, so we'll say 3x plus 4. Now my answer, since this is a negative 5, there's nothing I can put in for x to make this be a negative 5 when I take the absolute value of it, so the answer is just no solution. Alright, so we did our second part in the blue. Now our third part is, can you write an absolute value equation that has one solution? So we know how to figure out 2 solutions. We know how to figure out no solutions. If we want one solution, that means that both of our, let's think here, one solution. would mean both of our solutions have to be the same. I'm going to look in the book here for a second for an example that would work. That's just one solution. That one's a little tricky. See if you can think of one while I'm looking in the book. I don't think that there are any possibilities where you could just have one solution, because you'd always need to get the negative in the absolute value bars and the positive to get the same absolute value. So I would say that you cannot write an equation that has one solution. Okay, the temperature of a cage for a pet gecko should be about 80 degrees Fahrenheit, give or take 5 degrees. Find the maximum and minimum temperatures. Write and graph the range of acceptable temperatures. Okay, so we've got a lot there. We've got 3 different sentences, so I'm going to break this out into my 3 different sentences. Okay, so first our story problem. The temperature of a cage for a pet gecko should be about 80 degrees. That's where our gecko is going to live and feel the best. Okay, give or take 5 degrees. So that means our gecko can still live comfortably 5 degrees over 80 or 5 degrees under 80. So that means my minimum, if I take away 5, would be 75 degrees. My maximum, if I add 5 degrees to 80, would be 85 degrees. So all I did was I took this and I added 5 to get that, and I subtracted 5 to get that. So our range that our gecko can live comfortably would be anywhere from 75 degrees to 85 degrees. Now if I graph that on my number line, obviously we don't want to start at 0 and go all the way up to 75 because that's going to be a really long number line. So I'm going to pretend this right here is 75, and we'll count by 5. 75, 80, 85. So this right in here is where, anywhere in there is where my gecko could live comfortably. A survey shows that 65% of 8th graders like to watch horror movies. There is a 3% margin of error for the survey. So there's our situation. I'm going to block that off. Find the maximum and minimum percentage of students that watch horror movies. So that's what we're trying to find. And then write and graph the range. Okay, so this time we're starting with 65%. Our margin of error is 3%. So if I subtract 3, I'll end up with 62%. If I add 3, I should change my minus to in front here. If I add 3, I end up with 68%. So that's the maximum and minimum. That's what the first thing they wanted us to find was. And then our range would be anywhere from 62% to 68%. And then the last thing it says is graph the range. So I'll pick a spot here. I'll say that this is 62. Maybe I'll count by 2. So 64, 66, 68%. So anywhere within this range right here is how many 8th graders like to watch horror movies. Between 62 and 68% of 8th graders like to watch horror movies. The average temperature in a Canadian city is 1 degree Fahrenheit. The actual temperature may be 4 degrees warmer or cooler. So there's our situation. find the maximum and minimum temperatures, and then write and graph the range. Okay, so our temperature is 1 degree, give or take 4 degrees. So if I subtract 4 degrees from 1, I'll end up at negative 3 degrees. If I add 4 degrees, I'll end up at 5 degrees. So our range is anywhere from negative 3 degrees to 5 degrees. And then if I graph that down here, I'll say this is negative 3, and I'll count by ones. Negative 2, negative 1, 0, 1, 2, 3, 4, 5. So anywhere in here, in between this range, is where the actual temperature may be in a Canadian city. Summary. Solving an equation with absolute value bars is different because homework is pages 1 through 5 through 1 through 6, numbers 10, 25 to 31, 45, and 63. And page 819, make sure you're just looking at section 2.5 on that page, numbers 1 through 9.